to go through and do a blank, what it should look like if I give you a problem like this. And because we're going to end up having a bunch of them, there's a specific way that I want to label these. Up here in this top corner of your paper, this is 4-step process number 1. And right now we are in chapter 7. And for those of you who like colored things, I do everything in 2 colors. One color stays the same word for word, absolutely gets written the exact same way. My other color is things that you fill in every problem. So if you are a color person and you have colors with you, get them out. Now, does it matter if you do 2 colors or not? No. But I prefer to. All right, so this is a generic 4-step process for using sampling distribution.
Which color of yours is going to be with?
This is, I'll do this different. I'll switch and I'll do it like this, and I'll tell you when I get there. Using sampling distribution of p hat to find the probability. So the problem we just did was one of these, but we asked it in pieces. So this will be like the whole process that you go through by yourself if it's not asked in pieces. All right, so everything I do in green is going to be like basically where I start. Is things that are written exactly word for word every time, and then anything I write up to the side of it in orange is things that will change problem to problem. So with pretty much every single problem we did yesterday, which means whatever homework, I first started by asking you, let's read this problem. Now, what is our what and what is our what? Population and sample. So we want to write those out. If you don't do 2 different colors, at least do like parentheses or something around the stuff that has to get plugged in. If you want colors and you don't have any, ask somebody around you, or I probably have color pencils or something somewhere if I need to get them. So population, sample, those are context things. So just coming back to a problem we did in the homework, let's say here we said our Florida registered voters was our population. The Florida registered voters that were contacted by the random digit dialing service was our sample. What else context could I write about that problem since we're talking about proportion? Like we're trying to find the ones that what? For that problem. So the registered Democrats is the other thing. So I want to write that in here as let me define what I'm finding the proportion of. So I am defining P. Well, P is a what? Proportion. That's never going to change. P is always proportion. and then define it in context. And so we're doing this whole problem to find a probability, because that's where we started. That's what we said. That's the type of problem this is. So I'm going to write out what probability it wants me to find. And so with the problem we just did, what symbol did I put here? I'm seeing if my what is between different numbers. D hat. Now, I'm writing this one generally to be between two numbers. Is every single probability we find between two numbers? Sometimes it's greater than, sometimes it's less than. So, I mean, that can differ a little bit. But you're just writing a P parentheses for whatever your context is. So state is stating the different things about the problem. Plan is kind of checking any conditions or requirements that have to be met. So what's the first condition or requirement that we said we had to check through in that problem on the left side of the notes we were just doing? 10% condition. And I usually write a question mark because I'm saying I'm checking to see if it is or isn't. Now am I going to grade you if you do a check mark or a question mark or no? What is our 10% condition? I am checking that capital N is
greater than or equal to 10 millimeters. And that translates to what?
that our population size is at least 10 times bigger our sample. So in the problem that we did on the left, at this point, I would have done what? Like literally right below it, I would start doing what? What did we do right below this on our paper? I plugged in my numbers. So math. And then what else did I do? What did I write beside of that? What did I write literally beside the number that we came up with?
Population at least. Yeah, I don't know if we wrote that on our paper. We wrote a different on the approximation.
Oh, I didn't have you write that part too. Oh, yeah, you did. There, it should have said there are at least 15,400 adults. And you can write, I don't care if you do this, but this would be 10 in population. I don't want to write that, that gets confusing because it's individual population. And then you write that part out in context. Alright, so that gets us through the 10% condition. What's the other requirement condition thing that I had to check? See if it was normal. What did we check to see if it was normal?
To see if this has to greater than 10.
And how do I find that?
Okay.
And n times 1 minus p. I don't mind if you go ahead and do this and go straight into plug in your numbers. That's either writing it horizontally or vertically. Like I wrote it vertically on the other problem, it doesn't really matter.
What?
Like I actually did n times p and then the number below it and then plugged it like. So when I did it in my example, I just plugged in numbers below it this way instead of that way, but that doesn't matter. And then once I have all that, I have to write out to the side. There are what this time? And I'm going to write in sample. And I'm being funny about this should be right now. I'm saying are, even though it's technically should be, even though y'all probably have no idea what I'm talking about right now. That's fun. So I'd actually plug that in. Like jog and not jog. And I have to finish this section with one what statement. I am very, very, very nitpicky on these. But I am also telling you that they get super, super, super repetitive. So if you can get it nitpicky initially, life gets really, really easy for you. And heaven forbid this class starts becoming easy. So the better you can understand this earlier, the better off you are. So plan was checking conditions. So do is actually doing the math. So what's the first mathematical thing we found out from this problem? On the left side.
Probability.
Next thing. Well, before probability. Before that. We had to find our standard deviation or our mean first. So what is our symbol for mean? And I know that mu of p hat equals what? What's our equation? P. And then I'd actually plug in a number. Then I would do standard deviation, sigma of p hat, which equals what?
Square root of p times 1 minus p over n.
Numbers plugged in and an actual answer. But what do I need to write beside of that? So I can only use standard deviation equation if the 10% condition applies.
Where's b/2?
Because.
That's why I thought.
Yeah, I don't shorthand very much. So now, from the top part, I have my mean, I have my standard deviation. I've already checked both of my conditions, so we're essentially down to part D for the problem. So now I write out what?
The probability.
And then depending on whatever it is, whatever my numbers are. Now, sometimes I have 1Z and sometimes I have 2. I didn't do this the first time. I did 4-step process, but then I had somebody go back and like that I added this, so this is totally up to you. They like calling this one number A and this one number B. So that here, this is number minus what? Number A divided by number B. If you would have known that and don't think it's worth writing down, that's fine. But some people found that part helpful. And so I might have 2, but I don't always have to have 2. So I'm only writing 1 for now. The same process, just the other one. At that point, I do what? Rewrite my probability in terms of Z. And then what else do I have to do? And if you go to the left or over there or down or over there, I don't care which one, but I want to show that. How do I show that? Draw it and shade it. And because some of you are going to choose to use the calculator, I'm not going to write on here to write down the initial area for your Z's, but some of you are going to find that, and that's fine. And then you're finding the area of the shaded. However you choose to do that, whether you actually use the yellow sheet or use your calculator's version of the yellow sheet. All we have left is conclude. So conclude is essentially going back to our homework part C from number 9 and number 10. We made our distribution of dots. Where does that dot now fit? Does it seem like it would work or not? So,
Our little targets?
no, the one we're like, that one. If we were to randomly select in individuals, so in that past problem that would have been 1,540 adults. When the claim actually is true, so like the population actually is 15%. The probability that essentially what we're looking for is this number. So the one we did on the left-hand side, and I know you're writing this fine, would be saying if we were to randomly select 1,540 adults when p equals 0.15, the probability that we get between 13% and 17% jogging is 0.9722. And I know initially people get frustrated by the tediousness of this, but realize that has there ever been anything in our class up until now where I can literally hand you a template to follow and just say, now follow this? No, not even anywhere close. So it's nice to have a template to follow exactly every single time. Every process is the same.